I didn't get the first one.
Oh, I've sent it to the platform. So if you are not getting it, you can pick it from the platform. Okay. But it goes like a horizontal uniform rod of mass 5 kilogram and length 2 meter is supported at each end by wires suspended from a ceiling. If a mass of 4 kilogram is placed 0.4 meter from one end, find the tensions in the wires. A horizontal uniform rod of mass 5 kilogram and length 2 meter is supported at each end by wires suspended from a ceiling. If a mass of 4 kilogram is placed 0.4 meter from one end, find the tensions in the wires. Okay. So let's go to the board and then draw this. So the information we have is that a horizontal uniform rod. So we have this a horizontal line representing the rod. Okay. We are told it is a uniform rod. Now take note. If a moment question tells you that we have a uniform rod or a uniform bar, what it simply means is that once it is uniform, the total weight or mass, the total mass or total weight acts at the center, at the midpoint. Once it's a uniform rod or uniform bar or plank, what it means is that its total weight or center of mass, center of gravity acts at the center or the midpoint. So here we are told that this rod is suspended from both ends, okay, both ends to the ceiling. So we have a string connecting one end to the ceiling. We are using this to represent the ceiling. The other end is also connected to a string and then to the ceiling. So this point becomes the ceiling. So this is the length, this is the rod. This is the rod. The length of the rod, we are told, is 2 meters. Now, because it's said to be a uniform rod, its central mass, center of mass would act at the center. So the mass of the rod is 5 grams. So when I divide 2 meters into equal parts, 1 meter each, this is where its central mass, 5 grams, would act, 5 kilograms. Please, are we fine? Are we okay?
Please can you go over?
Okay. So this rod of length 2 meters is suspended by strings to the ceiling. So this thing represents the ceiling to which the rod is connected to. We are told that it is suspended or connected to the ceiling by strings. So these straight lines to the ceiling represent the strings holding the rod. This is the rod. Let me draw a hand. This is the rod, a uniform rod. This is the uniform rod. Now, we are told that the rod is uniform. Once it is a uniform rod, it means its weight or mass will act at the center, its midpoint. So if the total length of the rod is 2 meters, the mass would act or will be exerted at the 1 meter, okay, midpoint of the rod, because we are told it's a uniform rod. Put that down. If the rod is uniform, it implies that its total mass or weight would act at the center. Please put that down. If it's non-uniform or the rod is not uniform, the question must tell you where the mass would act, or you, the learner, would have to find it. We'll be solving similar questions. So we'll look at a situation where it is not uniform. But if it is uniform, the total weight would act at the midpoint. Are we fine? Are we okay?
Yes,
Yes, yes, please.
Good. So that's why the weight of 5 kilograms is. So from here to here, the distance from the ceiling to here must be 1 meter each. So 1 meter each. Let's continue with the question. The next information given is that if a mass of 4 kilograms is placed 0.4 meter from one end, if a mass of 4 kilograms is placed 0.4 meter from one end, find the tensions in the string. So we have a mass of 4 kilograms placed at 0.4 meter from one end. Here, the question never indicated where the mass, okay, is suspended. All that we are told is that we have a mass of 4 kilograms, which is placed 0.4 meter from one end. So it can be from this end or this end. These are the ends of the rod where the string is connected. So if I'm choosing the right end, then from this point to this point, that will be where the 4 kilogram weight will be at. So from one end to where the mass is, the distance must be 0.4 meter. I can equally have it here. From this end, if I measure 0.4, I can place this, because we were told that from one end, it can be any end. Are we okay? Are we fine?
Yes,
Okay. Now we are to find the tension in the string. So the tension in these strings connecting the rod to the ceiling will be directed to where the ceiling is, where the fixed point is. So we have a tension T1 in the string. We have another tension T2 in the other string. So these are the tensions in the string. This will produce a tension directed to the ceiling, and then the other end would also produce a tension in the string directed to the ceiling. Are we okay?
yes, please.
Okay. Now, To calculate for the tension, we are, you see, solving problems with moments, we are always using the principles of moment. What's the first principle? Sum of forces in one direction must be equal to the sum of forces in the opposite direction. So what are the forces in the upward direction? T1 plus T2 must be equal to the downward forces, which is 5 kilogram times 10 plus 4 kilogram times 10. We are converting the masses to kilogram. So we have T1 plus T2 being equal to 90 Newton. Are we okay? Are we okay?
Yes, please.
Let me produce, instead of this, let me take this as knife edges or pivots. What it simply means is that we have a support or pivot here, and that represents T2. We have another support here. Okay. This pivot, which is the point where the thread holds the bar, produces a reactional force, which here in our question or in our situation is being represented as T2. This would also produce a reactional force, which in our case is represented by T1. We have the weight of the bar or rod, 5 kilogram or 50 Newton. We have the mass, which is 4 kilogram or 40 Newton. Now the distance from this, the end of the rod to this, we are told is 0.4 meter. So actually, this situation is the same as this. Okay. Now when you have these situations, two pivots, how do we solve it? You always solve two pivot questions, okay, as if you have one. So you are free to eliminate one of them. It can be this, it can be this. Whichever way you look at it, you need to get the same results. So I can take the moment or the turning effect around one of them. Okay, either if I say this is P, this is Q. This pivot or knife edge is labeled P and Q. I can take the moment around Q or the moment around P. The choice is yours. So in taking the moment around one of them, it's like as if one is not in existence. I am choosing to take the moment around P. So I'm cleaning out the support at the support P. But when you eliminate one, it does not go with the reaction. Deborah, your hand is up.
Mr. Dia, please, why do you multiply the mass by 10, but not 0.1?
Because Deborah, I have to see some of these basics. You have to have a quick eye to see some of these things. You've forgotten these are masses given to us in kilogram. Are you okay?
But Mr. Dia, I thought you say when it's in kilograms, we should multiply by 0.1.
When it's in gram.
Okay.
You have to see it. Okay, so when you have two pivot situations, you can always eliminate one of them. You are free to choose any and take the moment around one. Whichever moment or pivot you eliminate, it doesn't go with the reaction there. So the fact that I'm eliminating kill does not mean T1, which is the reactional force, will not be there. It will be there. If it is not there, there is no way it will balance, because we have, if this is not there, look at what will happen. Assuming the reaction T1 is not there, it means the turning effect will only be one-sided. Okay, 5 kilograms would give us a clockwise moment. 4 kilograms would also give us a clockwise moment. So the system will never balance if you eliminate the reaction. Please, are you okay?
No, please.
Mr. Dia, please repeat it.
Please come again.
Initially, this is what I have. I said this situation is similar to where you have two pivots on which the rod is being supported. So we have the pivot P and then the pivot Q. This pivot Q gives a reactional force T1. Just as the original question. In solving two pivots problems where you have two supports, we solve it by always taking the moment or the turning effect around one of the pivots. So you take it around P or around Q. Whichever way you go, you must get the same results. What it means is that I can presume this is not there. This support Q is not there. But what I'm saying is that in eliminating Q, it doesn't go with the reactional force there, T1. The reactional force must still be there. If P is what you are eliminating and then working with Q, you can clean the pivots or the ninth edge, but it doesn't go away with the reactional force T2 over there. Are we fine? Are we fine? Now, if
Please come again. It was breaking.
Messiah, it is breaking there. You are using it as a bait. Okay.
Oh, Mr. Dia, is true.
Okay. What I'm saying is that if we are eliminating this, meaning we want to take the moment around P, Q is not there, but Q eliminating the pivot or the ninth edge does not go away with the reactional force produced by the pivot. It will still have to be there, in a sense that if this is not there, we will only have 5 kilograms giving us a clockwise turning effect. That's giving us a clockwise turning effect. So the next turning effect will be clockwise. So in a situation like this, there's no way the system will balance if this is eliminated. So you are free to eliminate one of the pivots, but it doesn't go away with the reactional forces produced by them. That's what I'm saying. Okay. All right. Good. So taking moment around P, it means we are taking moment around P. 5 kilograms will give us clockwise moment. 4 kilogram would give us clockwise moment. This reactional T1 would give us anti-clockwise moment. The turning effect produced by T2 will be 0 because the perpendicular distance is 0. Are we fine? Are we okay?
Yeah.
Okay, so let's look out for sum of clockwise moment. The sum of clockwise moment. If we take the 5 kilogram, which is equal to 50 Newton, 50 Newton times, what is the perpendicular distance from the 5 kilogram to the pivot? Yes. What's the perpendicular distance?
2 meters.
No. What's the perpendicular distance from the 5 kilogram or 50 Newton weight to the pivot?
0.9 meter.
It is, yes, somebody said it. It is 1 meter. 1 meter because what is the 5 kilogram? What is it? What is this value? 5 kilogram. What
5
is it?
pieces at the center.
It is the 5 kilogram is the weight of the bar, the weight of the rod. And I told you that once the rod is has a uniform cross section, its weight or its mass will act at the center, its midpoint. The whole length of the rod is 2 meters. Okay, so if it's a uniform bar and so its mass will act at the center, then dividing the whole length of the rod into 2 from where the mass is to one end will be 1 meter. So this will be times 1 meter plus.
You said I have a question.
Ask your question.
Is that 50 times 1 meter?
Madam, it's 50.
Yes,
Yeah.
that's 50.
Please, why?
We are converting the masses into weights.
Okay, so you can't use masses.
The rule is that sum of upward forces must be equal to the sum of downward forces.
Yes, please.
Okay,
Mr. Dia, please, is it 50 times 2?
this is 50
Times
times
1.
1 meter
1, okay.
because the weight, the mass of the bar acts at the center. Okay, so we are looking at the sum of clockwise moment. 40 Newton times, what's the perpendicular distance from the 4 kilogram mass to the pivot?
1.86.
Exactly. That will be 1.6 meter because we are told this is 0.4 meter from one end. So if from here to here is 0.4, then what will be left will be 1.6. Good, Deborah. Just meter to help you. So this is 50 plus, what is 40 times 1.6?
64.
54.
64. 64.
That's it. So 64. Good. Let's look at sum of anti-clockwise moment. So T1 is giving us anti-clockwise moment. Okay. What is the perpendicular distance? Okay, from T1 to the pivot. What's the perpendicular distance?
2 meters.
2 meters.
Exactly. Okay. So it means 2 meter times T1 is equal to 114. Therefore, T1 would be 114 divided by 2. And what is 114 divided by 2?
57. 57.
Well, this is 57 Newton. If T1 is 57 Newton, then from equation 1, this is what we got. Sum of upward forces must be equal to the sum of downward forces. So T1 plus T2 is equal to 90. Therefore, T2 would be equal to 90 minus T1, which is 90 minus 57, which will be equal to
53.
So the tension in the string T1 is 57 Newton. The tension in the string T2 is 33. So easy to solve. Or
Stadia.
yes,
Please take a screenshot, please.
You see, lost me when we saw the 114.
come again.
I got confused at the 114 part.
114. Okay.
Yeah.
So we looked at the sum of clockwise moments. Ado, are you there?
Yes, please.
Okay. We look at the sum of clockwise moments. And what is it? This one constitute clockwise when you turn the bar. Both forces will turn, okay, to the direction of the force. The forces are pointing downwards. So if this represents the 40 Newton, when it will turn clockwise, this will also turn clockwise. So we are looking at the sum of clockwise moments. Okay, so 50 Newton times the perpendicular distance, which is 1 meter. Then 40 Newton times the perpendicular distance. This is 1. Okay, this is 0.4. So if the whole length is 2 meters and this is 0.4, then from here to here will be 2 minus 0.4, which is 1.6. Imagine for you. Good. So this gives us a turning effect of 50 Newton meter. This also gives us a turning effect of 64 Newton meter. So and so this is it. The 114 is for the sum of clockwise moments.
Oh, okay.
Okay. Then we look out for the sum of
Thank you.
anti-clockwise moment. Okay. This will give us an anti-clockwise movement because when you pull it, it will turn upward this way. Okay. So
Yeah.
T1, which is the force there, times the perpendicular distance, 2 meters. Okay. So this is the anti-clockwise moment. We have 2T1. Then the law of equilibrium or balance. Sum of clockwise moments should be equal to the sum of anti-clockwise moment. That's why we are equating this to the 114.
Okay, thank you.
Okay, so the moment you get T1, your T2 would also be on the table. Okay, so the question sometimes looks ugly or weird by its wording. But when you apply the principles of movement, you realize it isn't anything so difficult. Any question? Any question? Hey, somebody asked that I take a screenshot. Do you still need it?
Yes, please.
Okay. Any question? In fact, as for today, I've really suffered. You have made me suffer. Network torture. and I'm already exhausted. Okay, so I've sent the solution. Okay.
Mr. Dia,
Hello.
please, the T1, is it the tension in the wire?
Yes, we have two wires supporting the rod to the ceiling. So T1 and T2 are the tension within the wires which connects the rod to the ceiling.
So what we found, the T1, is it just for, it's for all the wires? The T is just, it's for the rod and the wire, or?
The concept is like this. So I have this as the rod. This is one wire or thread connecting it. I have another one to the other end, connecting this to the ceiling. Okay. Okay. So
Yes.
the strings or the wires hold the rod in position in this manner. So the T1 and the T2 are the tensions within this wire and then the other wire held to the ceiling. Okay. All right. Okay. So we have 8 minutes. I've sent the solution to the platform. I want to take a shot of another similar question and then send it to you to try. Use the rest of the 8 minutes to try. Okay. We have a class tomorrow too. Maybe we'll revisit this because of the network problem. If that is what you vouch for, we can revisit it. Then if you don't want us to go over, we can do a new thing. But after going through the features or the attributes of moments, you are now free to be trying your hands on different questions. Moment questions is about English language. If your understanding of the statement or word problem is good, you can easily decode what and what to do in moment questions. So I'll send some similar questions to the group. You try, and then we prepare ourselves for tomorrow. So this is why I'll end today's meeting. If you don't have any question, let's call it an evening.
Mr. Adrian,
Hello.
and please tomorrow the class, please, what time?
Certainly will be 9:30 from 9:30 or 9
Yes,
o'clock,
please.
9:30. I will want to even